Dear students, and welcome back once again to this video tutorial. Today we're going to start a new chapter, that is chapter 3, organization of data. So in this chapter we're going to learn a very basic thing. This is just a revision of what we studied in class 10 math. We're going to study about what is continuous series, what is discrete series, what are the different type of frequency distribution. All right. So I'll just let you know the brief introduction, and after which we will start with our practical questions. So here in quantitative variables, it can be divided in two types of. So we can say that there are two types of quantitative variables. Number one is continuous variables. Yeah, continuous variables, and the second one is discrete variables. Continuous and discrete. So when we talk about continuous variables, in continuous variable, the value or any value that is within the range of numbers, you can say it falls under continuous variables. All right. So it says continuous variable is any value within the range of numbers. So that is why we often see that there are numbers between a range of class interval 0 to 10, 10 to 20, 20 to 30, like that. Yeah. So here in continuous variables, uh, any value within the range of numbers are, are called continuous variables. And in discrete variable is the one whose values change by whole number but not as a fractional value. For example, number of children in a family, number of students in a class. And again, there are different types of frequency distributions. We have open-ended, bivariate, cumulative, relative, and percentage. When we talk about open-ended, so let me just write it down here. There are different types. Number one is open-ended. Number two is bivariate, cumulative, relative, and lastly, percentage. So here, mostly, we're going to be focusing more on cumulative, relative, and percentage. In very less questions, there are no questions about open-ended question or bivariate here. Uh, in this chapter, we have more of cumulative, relative, and percentage frequency distributions. So without wasting much time, we will go ahead and then learn about some frequency distributions which you will see in in this chapter. So here I hope you know what you mean by class limits. Yeah. First thing that you have to know about frequency distribution is you have to know what is class limits, what are class intervals, and what class frequency and class midpoint. So class limit. Let's just take an example of class interval. Say 10 to 20, 20 to 30, and 30 to 40. Let's take discontinuous variables. Yeah. So in class limits, the lowest and the highest values that can be included in a class are known as class limits. The lowest value of the class is known as lower limit, and the highest value is known as upper limit. So here, if we're taking this class as 10 to 20, 10 is lower limit and 20 is upper limit. Okay, so here this is class limit. Now when we talk about class interval, the difference between the upper limit and the lower limit. So class interval. The difference between the upper limit and the lower limit. So 20 minus 10 is 10. So our class interval is 10. Our class frequency, if the let's say um, our frequency here is 5, 10, 7. So class frequency, if we're taking the class limit as 10 to 20, our class frequency is 5. So our frequency is here 5. Okay, and midpoint, how do we find the class midpoint? Now, how do we find the class midpoint? So to find a class midpoint, what you can do is upper limit plus lower limit, that is 20 plus 10 divided by 2. So if you add up this one, you'll get 30 by 2, and it is 15. So our class upper limit here, class midpoint here is 15. All right. Okay. So these are some few points that you have to learn when we're talking about frequency distribution. Now, I also want there are another topics which you have to be aware of in frequency distribution, that is inclusive and exclusive class intervals. So let's learn about that right now. First is exclusive method. So whenever you see a continuous variable, you always have to first check out whether it is exclusive or inclusive. So how do we know what is exclusive? Now, for example, here we take up class limit as 0 to 10, 10 to 20, 20 to 30, 30 to 40, for example. Yeah. So when we, how do we know when whether the frequency is exclusive um, method? So when the data are classified in such a way that the upper limit of the class interval is the lower limit of the succeeding class intervals, then it is said to be exclusive method of classifying data. What it is saying is that when the upper limit is the lower limit of the succeeding class interval, then it is called as exclusive method of classifying data. So here you see 0 to 10, and this upper limit 10 has become now the lower limit of the succeeding class interval. So 0 to 10, 10 to 20, 20 to 30, 30 to 40, and uh, it will go on like that. So as simple, if it is repeating like this, if the upper limit is repeating again in the lower limit, then you will know that it is exclusive method. Okay. The other one is inclusive. Now, inclusive method, example 0 to 9, 10 to 19, 20 to 29, 30 to 39 here. It is not repeating here. If you look here, the number upper limit is not repeating in the lower limit again, right? So when you see such like this, then it is called this kind of frequency distribution, continuous variable, will fall under inclusive method. Now, one thing that we have to know is that um, when you find anything like this, inclusive method, uh, if you're asked to convert this inclusive method into exclusive and then find the answer, then what you have to do is you have to subtract, okay, minus zero point 0.5 from the lower limit and add zero point 0.5 from the upper limit. All right, so if we have to take this portion and then remake it into exclusive, then it will be somewhat like this. If you minus zero point 0.5 from 0, it will be 0.5 only, right? Yeah, so you can say minus 0.5 by 9.5. Now if you subtract again, if you subtract here again, it will become 9.5. Next, add up 0.5, 19.5. If you subtract 0.5, it will become 19.5, 29.5, 29.5, 39.5. So you see now it has become an exclusive method. Now it is repeating. the upper limit is now repeating in the lower limit of the succeeding class interval, right? So this way you have to first make it into exclusive and then start calculating. All right. Now, one more thing that you have to understand here is in exclusive method, whenever, for example, if there are certain numbers given and then you are asked to calculate tally and then find a frequency. Now, if it is 0 to 10, you will not be using, you will not be counting from 0 to 10, but you will be taking values only till 0 to 9. And the 10th value you will be taking in a succeeding class interval, okay? And here from 10 to 19. And here 20 to 29, 30 to 39. All right, that I'll let you know again if you're confused while solving it. I'm sure everything you will have no doubt after which. So let's start with the solution. I'm going to show you one question, that is question number 1. It has it is talking about discrete frequency distribution. So we will first solve question number 1, that is construct a discrete frequency distribution for the above data. And after that, we are also going to make a frequency distribution according to the hint given here, and then convert the given frequency distribution into an a continuous class interval or an exclusive method of frequency distribution. So I'm sure once we solve question number 1, you will have no problem uh, in solving the rest of it. So let's go ahead and solve question number 1. All right. So I've already calculated here just to save time. So I'm just going to uh, clarify or explain to you how I have solved this question. So the question number 1 here, it says 30 students obtained the following marks in the statistics examination, and these are the following marks of 30 students. Now, we are asked to calculate or construct a discrete frequency distribution for the above data. So now I hope you remember when we talk about discrete series, we said in discrete series is more like if you have a number of students and then one examination, yeah. So how much now we have two variables here. We have 30 students and then 30 marks of all those 30 students. Now what we're going to do here is we're going to check out the lowest marks and the highest marks. Okay, so if you see here, the lowest mark is 21 and the highest mark is 69. Okay, if you look into your table, you will see that. So 21 and 69. So what I want you to do is, since it is marked, so you can write on top of it heading as marks, and you can write down not all the marks from 21 to 69, but then what all marks you see in the like following numbers. So I see 21, 25, 29. It has to be in either increasing order or decreasing order. Okay, so I wrote it in the increasing order. So that is 21, 50, 25, 29, 30, 32, 34, 35, 36, 38, 49. Sorry, 39, 40, 47. Um, 50, 52, 53, 54, 57, 60, 58, 63, 67, 68, and 69. So what I've done in the next is that I have written tally here, and I've given marks, the number of marks that is repeating. So from here, from the table, I see that 21 is repeating just one time, so I've given one mark here. Okay, 25 is repeating three times here, 25 1, 25 2, and the other 25 somewhere here, 25 3. So I've written 3 here, 1 2 3. So I hope you know how to do this one, tally. You keep on doing the same thing for all the numbers, and then write down the frequency here. Since it is 1, so you write 1 here. So this is 1 2 3, so you write 3 here. 1 2 3 1 1 1 1, like that. You write it down and make sure that the total should be 30 here. So this is our discrete series. You have a number, marks, and you have a number of students scoring, 30 students scoring all these different marks. Okay, so this is question number one. Question number one, bracket A, that is construct a discrete frequency distribution. So I've also calculated the second one, that is frequency distribution. It says make a frequency distribution using the following classes. They have already given the classes, that is 20 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 to 69. So here 20 to 29, I have 5 frequency. If you see here, 21, 25, 29. Since it is inclusive, so we can take the whole, all these numbers. 1, 3, 4, 5. So I've written here as 5. 30 to 39 is 10. So if you see 30 to 39, 30, 2, 3, 5, 6, 7, 8, 9, 10. Till 39 is 10. So I've written down 10 here. 40 to 49. Let's see, 40. 1, 4, 5, 6, 7, 40 to 49, right? So 3, 4. So it is 4. 50 to 59, 50 to 58, till 58, because there's no 59. 1, 3, 4, 5, 6, 7. So I've written down 7 here. 60 to 69, 63, 1, 2, 3, 4, 4. So if you add up all the frequency, you should also get 30. Okay, so this is the second answer. Now in the third C bracket, you are asked to convert this continuous class interval and make a frequency distribution table. So now convert this inclusive into exclusive. Okay, when we say continuous, it is like the number is repeating again and again when we do that. Yeah, so like I said, when you do inclusive, how do we make exclusive? You can subtract 0.5 from the lower limit and add up 0.5 in the upper limit. So this is what I've done here. 20 minus 0.5 is 19.5, 29.5 plus 0.5, 29 plus 0.5 is 29.5. So 19.5 to 29.5, 29.5 to 39.5, 39.5 to 49.5, 49.5 to 59.5, 59.5 to 69.5. So this is what I've done. There will be some changes in the frequency as well. So first you got 5, 10, 4, 7, and 4. Now I got 4, 11, 4, 7, 4. So if you add up all this, you should get 30. Alright, so this is how you make continuous frequency distribution. So this is question number 1. So now I'm going to show you one more time of how to do inclusive and exclusive in question number 2. And with that, I think this would be it. I want you to prepare the frequency distribution for the rest of the questions by yourself, because it's all the same. Alright, so next, this is question number 2. Now again in question number 2, first one, you are asked to calculate, construct a frequency table of inclusive and exclusive series with an interval of 5. So we are asked to calculate inclusive as well as exclusive with an interval of 5. That means the difference should be 5. So for that, what we have to do is we have to check out from the given data, we have to check out the lowest and the highest value. So the lowest value that I see is 10, and the highest value that I see here is 38. All right. So what if it is interval of 5 in inclusive, so 10 to 14, so 10, 11, 12, 13, 14. So if you count from 10, 10, 11, 12, 13, 14, so this is 10 to 14 will be a 5 interval, right? So I've made an inclusive frequency table by 10 to 14, 15 to 19, 20 to 24, 25 to 29, 30 to 34, and 35 to 39, because 38 is the highest, right? So write down tally here, and what all number that falls under this range from 10 to 14, you please make a tally and then write down the frequency here. So it's 1, 2, 3, 4, 5, 1, this is 6, 5, 10, 13, 5, 6, 7, 8, 8, 5, 6. I've written down 6, 5, 5, 2, 2. Again, when you add up all the frequency, it should give you 40 because the number given, the total data given in the question is 40 data, right? 40 marks. Now, so this is inclusive frequency table. Okay, now how do we make again exclusive? Now, similarly here, you don't have to plus minus here if you are asked to do, make a, in exclusive method, make a table of 5, then you can say 10, 10 to 14, 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 45 to 35 to 40. This way you can do. Now the frequency will be same because even here, even though it is exclusive, we are just going to count till 14 only, right? 10 to 14, and from here 15 to 19. So this value would be same. Okay, so this one, if you are asked to calculate the inclusive frequency table from this data, then you will have to subtract zero point 0.5 here. If not, if you can directly get it from the data, you can directly get it, make it like this. Okay, 10 to 15, 15 to 20, like that. So this is it for question number 2. Okay, so this is it for this tutorial. I'll be making one more tutorial for this unit wherein I'll be explaining about how to make a less than and more than, a cumulative frequency and relative and percentage method. Okay, so this is the first part of the tutorial. I'll be uploading the second tutorial very soon. So take care and I'll see you soon.